Fermat Primality test. The Fermat Primality test is a probabilistic test to determine whether a given number is a probable prime. Primality test algorithms, they are divided into two broad categories: deterministic algorithms and probabilistic algorithms. Deterministic algorithms always gives a correct answer, that is a prime number as a prime. If you input a composite number, it will give composite as a result. The next category, probabilistic algorithms, gives an answer that is correct most of the time but not all of the time, because there is a chance that if you give a composite number as input, the output may be prime. We know the Fermat-Little theorem states that if n is a prime and n not divides a as an integer, then a raised to n minus 1 congruent to 1 mod n. We will choose a such that 1 less than a less than n minus 1. According to this test, a composite number does not hold this congruence. But Fermat pseudoprimes and Carmichael numbers give wrong result. No. Fermat's little theorem, a raised to p minus 1 congruent to 1 mod p. If p now divides a, p is prime and a is an integer. If n is prime, then for any integer a raised to n minus 1 congruent to 1 mod n. For an integer a, it should satisfy this congruence, a raised to n minus 1 congruent to 1 mod n. A is called the base. A composite number or a non-prime number n that fulfills a mathematical condition that most other composite numbers fail. Pseudoprime. For example, the number 341 is a pseudoprime to the base 2. That is 2 raised to 341 minus 1 congruent to 1 mod 341. According to Fermat's little theorem, this congruence will be held if n is a prime number, but 341 is not a prime number. A raised to n minus 1 congruent to 1 mod n. This congruence will be held if and only if n is a prime. But here 341 is not a prime. Now let us see the factorization of 341. 341 can be written as 11 into 31. This for 341 has factors other than 1 and 341. So it is not a prime number. Other base 2 pseudo primes are 561, 645, 1000, 105. According to Fermat's little theorem, all these numbers satisfy the congruence 2 raised to n minus 1 congruent to 1 mod n. When n is composite for any a such that a raised to n minus 1 congruent to 1 mod n, then n is called a Fermat pseudo-prime to base a. If we do pick an a such that a raised to n minus 1 not congruent to 1 mod n, then a is called Fermat witness for the compositeness of n. 15 is a Fermat pseudo-prime to the base 4. According to Fermat's little theorem, a raised to n minus 1 congruent to 1 mod n not divides a, n is prime and a is an integer. 4 raised to 15 minus 1 mod 15 is equal to 1. It satisfies this Fermat's little theorem. So we call 15 a Fermat pseudo-prime to the base 4. Carmichael numbers. An integer n greater than 1 is called a Carmichael number if n is composite and GCD of a and n equal to 1 implies a raised to n minus 1 congruent to 1 mod n for all a belongs to the set of integers. In other words, the composite integer n is a Carmichael number if a raised to n minus 1 congruent to 1 mod n for every integer a relatively prime to n. For the examples, 561, 1105, 1729, 2465. We can write 561 equal to 3 into 11 into 17. 561 is not a prime number because it has factors 3, 11 and 17 other than 1 and 561. But any integer a raised to 561 minus 1 hold the congruence to 1 mod 561 for all a belongs to set 561 star.